of our global lecture series. This time we're gonna connect with New York. I see that Tehrani is already here with us, and I guess also the other are connecting. So it's a pleasure for us to have you here, Mr. Tehrani, Mr. Nader. And I leave 1 second the space to Marcella to introduce you. So Marcella, if you want to introduce our guest for the final lecture.
Yes. Thank you, Aldo. So good morning, everyone here in New York, and good afternoon and evening to all the other nodes in Tehran, Mumbai, Beijing, Barcelona, and Moscow. So it's my great pleasure to introduce Nader Tehrani as the closing lecturer of the YAC Global Summer School. Nader, thank you again for accepting our invitation. Nader Tehrani is currently the Dean of Cooper Union School of Architecture and Design Principal of NADA, a practice dedicated to the advancement of design innovation, interdisciplinary collaboration, and an intensive dialogue with the construction industry. Previously, he was a professor of architecture at MIT, Department of Architecture, where he served as head of the department from 2010 to 2014. For over 25 years, he worked to motivate academic research, to change practice, and to test new protocols in the context of academia. Working on interdisciplinary platforms, Nader Tehrani's research has been focused on the transformation of the building industry, innovative material applications, and the development of new means and methods for construction. Working between the digital realm and the medium of mockups, he seeks to simulate and generate alternative approaches toward tectonic studies. So that's also what we're going to do during the lecture. Nader has been recognized with the Cooper Hewitt National Design Award in Architecture, the U.S. Artist Fellowship in Architecture and Design, the American Academy of Arts and Letters Award in Architecture, among many others awards. Also, he has received GSS16 Progressive Architecture Award, as well as numerous AIA, American Institute of Architecture, BSA, and ID awards. In 2013 and 14, NADA was the top-ranked practice in design of Architect Magazine Top 50 Firms in the United States. He received a BFA and B.Arch from the Rhode Island School of Design, and he continues his study at the Architectural Association School of Architecture in London, where he attended the postgraduate program in History and Theory. Upon his return to the United States, he received his MA.UD from Harvard University Graduate School of Design. Please join me in welcoming Nader Tehrani to the YAC Global Summer School Lecture Series. Thank you.
Well, thank you for the introduction. Thank you for the invitation. I've prepared a series of projects that toggle back and forth between material studies, installations, and sometimes large-scale buildings, as well as buildings in the city, with the idea that the research that we do have some bearing on practice and how we get to transform the building industry from ground up. At the same time, as I look at some of these images myself, I realize that, well, this is the work of the last 20 years. By now, this has become the work of mainstream pedagogies. It's completely germane to most of your work. So the novelty of it is certainly already water under the bridge. And so the real question comes down to how this either gets scaled up or how it gets integrated into other design fields in more sophisticated ways. So I would suggest, and I leave it up to you actually, that we structure this as slightly more of an open conversation. And I don't know how well voices travel from Barcelona to Mumbai and Tehran and back, but in this room at least I have eye contact, so that if people want to just interrupt, I would welcome it, basically, because I think at a certain level, the nature of the presentation is broken down into small pieces or smaller ideas, and they're amenable to conversation rather than a linear presentation. Nonetheless, there are certain themes, and I can present them to you as little bullions of themes. Is that okay?
Yes.
All right. So essentially, when we started architecture, this is in the early 80s, essentially the dominant debates were between the waning moments of postmodernism and the rediscovery of history as a repository of typologies, forms, and organizations on the one hand, and a challenge to the academy by way of literary criticism, philosophy, deconstruction, as a basic conceptual dismantling of the institution. In a way, the closure and the autonomy of architecture. Both of these, in our education anyway, were productive and formative moments, but it's also significant to note that neither of these dealt with the advent of construction or materiality in any specific way. So, from our perspective today, what seems to be obvious as an engagement in theorizing construction, in expanding the definition of construction, or imagining alternative means and methods through digital manufacturing, through electronic integration, was a very remote concept at that time. So it's important almost to historicize the work, because within a certain context it had a certain different meaning. In that context, we got a call one day by Terry Riley, who was then the curator at the MoMA, asking us not to do an exhibition at MoMA, but rather an installation, a full-scale fabrication. For that, we thought, what would it mean to break out of the traditional trabeated forms with which steel is known, angles, I-beams, channels, and so forth, and begin to envision a laser-cut form whose structural logic and whose fabricational logic comes from essentially sheet materials with the same optimization as mass production, but through a process of tiling, imagining over 50 pieces of customized sheets that are then folded seamlessly into position. In this context, the stringer, as it were, the kind of the zigzag of steel elements, doesn't act as the structural element of the protostair, but rather the jig for its calculation in construction. In other words, imagine a steel structure over 50 feet long that is built to within a quarter inch of tolerance. The ability of the architect to have a direct relationship with the construction process was something that we tried to exact in collaboration with Milgo Bufkin, which is right down the street here, and whose presence on this work was critical. Obviously, the absorption of other forms of fabrication here, you can see from industrial design, the kind of scored seam of fast food boxes and so forth are here absorbed into the hardware of steel construction, what we call the stitched seam. It appears to be stitched, of course. The reality is that there's an offset score so that the continuity of steel is able to be rotated around a single sheet. And then in turn, trying to figure out what notions that are abstract have to do with the reality of performative steel. I mean, what folding did to the MoMA fabrication was structural, was fabricational. What it does to the McAllen building is establish a language of folding such that the staggered truss system, which is the structural argument behind this building, enabling over 72 feet of clear span becomes objectified within the context of this facade. Those three fins that you see on center projecting out are the only structural members that you will get on every other floor, enabling this kind of loft span. This is a building without any shear walls. It basically gains its structural currency by being a space frame. And by doing so, effectively it becomes a flexible machine, something that can withstand the dynamic fluctuations of market flows as you go from a sales building to a rental building, and as units begin to absorb each other. This is the narrative that lays behind this folding. In other words, what seems like an aesthetic operation is really an imprint, an index, if you like, of what the structural system enables. Going back to MoMA now, if you think that the folding is all about a structural ruse, no, it's also about a theme that Terry Riley wanted us to think through. And that is, think through the operations of an architectural process not through the eyes of the architect, but through the eyes of a contractor. What is plumb? What is level? What is right? What is true? These are all concepts that establish how you know when something's perfectly square and in alignment with gravity. Well, for a piece that has over 50 tiles, none of which are identical and none of which are actually plumb or level, from one perspective, you can identify that this has been built anamorphically with an incredible precision. So if you think of this as a structural form, at this moment, it itself undermines itself by becoming a flat canvas, a painting in dialogue with the possibility of this level of precision given such. So here, effectively, the narrative of the grid, the narrative of perfection, comes into confluence with the possibility of mass customization with minimal tolerances. That's me when I had a little bit more hair.
Sorry to interrupt, but is there a presentation that we should see, or is just?
Do you see the slides?
Yeah, exactly. I mean, if there are slides,
Yes.
everything is clear. We don't need to look and see images. But if there are slides, let's remember how to share the screen.
Okay, we didn't share it.
So it's
I guess they were waiting for it.
Which was share.
So Aldo, how do we share it?
Look, basically, you just can move your mouse to the left corner of the screen.
Yes.
And you will see in the window that some icons will pop up.
That's
The
right.
second one is screen share.
So we go to hand up.
Where's the left of the screen? Where?
On the Google Hangout window.
Google man. Sorry. All right.
Okay.
Okay.
There is the second icon on the left, which is called screen share.
Okay.
Yeah.
Exactly. There you can select which window you want to share with us.
I wish you had told us before.
Yes.
Recursive.
It's okay.
Hello, I see myself. Okay, now you're sharing the screen.
Okay, great.
All right. Very good.
You love it.
All right. I'm going to just, out of politeness to you all, give you 2 seconds of each of the images with all of those words.
No, I mean, we understood what
We're gonna go.
the discourse about, so.
Don't you think words and images have a relationship with each other?
Absolutely, but I think that sometimes imagination can also work as well.
Virtual sex, huh?
Right.
Okay, so I resume then. Here, we also recognize that, you know, the complexities of this construction process invariably has to deal with, you know, situations where you're dealing with complex programming, constituencies, and different public that you're dealing with. This is the RISD library, where the fabrication of these customized units is beginning to respond not only to differentiating circumstances of program, but the possibility of installing something prefabricated in less than a month within the space of the school year, because school years are so sensitive to construction periods. But more importantly, it's also demountable. And so notions of prefabrication are kind of embedded in this thinking also. Here you can see as the structure unfolds over the wall, it becomes less structurally sturdy. And because of that, it also gets more perforated to induce further lightness. This idea of perforation, of course, is embedded with possibilities of building perception. Here, in a project we did in Antwerp, the big concert hall, which happens to be placed in the zoological gardens, is a kind of an amazing concert hall. You know, when have you seen a concert hall in a zoo? And somehow part of the project was to imagine constructing a virtual and physical relationship between the two. And through the imperatives of building in an acoustic liner, we began to do that iconically, connecting the two effectively through a series of slats. This folding process is also been translated to other and more opportunistic moments like this in the Helios house, where effectively this is not a new structure, precisely because it is a renovation of an existing structural system that would have fallen out of compliance according to codes of 2010 in comparison to the imperatives of the 1970s when it was originally built. The tessellation that the folding affords is what expands the overhang in areas where you need it covered, for instance. In addition to that, of course, it absorbs some of the programmatic elements that you may need by expanding the column for the pay station, by absorbing the lighting system, the speaker system, and a variety of other things in it. In other words, it produces a hand-to-glove relationship, a structure-to-skin relationship that is looser, more malleable, and manipulatable to not only external constraints, the forces of code and setbacks, but also form making. Here's a detail where you can see the lighting elements that are inserted within that triangulation. Part of this journey of revisiting fabrication as a source of generating form led us to other fields. The sartorial trade takes us to possibilities of pleating, of darting, and for the immaterial, ultra-material exhibition at Harvard some 15 plus years ago, I discovered what a dart is. Probably most of you already know what a dart is, because anybody who wears an item of clothing knows that to navigate your curvatures, you need to excavate or cut a piece of fabric out. And cutting a wedge out of sheet material and rejoining it produces what is a ruled surface or a conical surface. And by doing that, you effectively, on the basis of a unit, are able to induce change of shape. In this case, of course, the negotiation with the grain of wood is what makes it also more exciting, because when you rip it beyond a yield point on one axis, it ruptures. And so we also tapped into, generations of work done by the Eameses and others to imagine how we would build something that is a bow truss on one side, an arch in the middle, and a wrapper, a skin on the other side, to create a connection between the lecture hall and the library, all the while imagining that these slits and slots may, in another project, be embedded with infrastructure. A way of imagining that the world that we live in, for the most part today, is a world of hung ceilings. And indeed, as we began to imagine our connection to projects, one such project emerged. I don't know, a 300 square foot pop-up pizza shop that basically merged the two projects, the MoMA installation with the GSD one, to imagine a triangulated diner surface that effectively took the existing infrastructure of that space, the mechanical systems, the diffusers, the lighting, the sprinkler systems, and produced the housing for it. You can see in the section where some of that effectively is snuggled up against the ceiling, and the surface, the sheathing, is effectively a shrink wrap, a virtual surface for the entire thing to be draped through the space. If it's not evident yet, for the most part, a lot of our material operations will bias some notion about the singularity of a material as the basis for the transformation of operations. In other words, to the degree that it's possible, all of our projects have eradicated hardware, eradicated products. And so here, for instance, in the railing, there is no bracket for the handrail. It is merely a bending or a deformation of the plywood sheathing that is the wainscoting of the stair in this case. In this detail for a shelving unit that is accessible from two sides and therefore does not have the sheer wall panel or the triangulation that a shelving would need, requires a moment's connection at that corner where it's structurally most feeble. And so the unraveling of that plywood as a composite structure in tandem with the steel produces the rigidity of a moment connection at that corner. And then again, going back to the larger scale, imagining how these operations on plywood are enacted on a larger spatial and morphological condition of a lobby in Antwerp. Our introduction to, and by the way, all of this presentation is not linear. I'm going back and forward in history, so but it's filled with anecdotes, effectively anecdotes of innocence. But when we were young, we got our first commission was a restaurant called Mantra, some 20-25 years ago, the budget of which was about $250,000, about 6,000 square feet. For that restaurant, we had proposed a small pavilion, smaller than this classroom, what was a hookah den, where back then you could smoke inside the hookah den. And for whatever reason, the budget that the contractor came up with for the hookah den was $200,000, leaving about $50,000 to be spent on the rest of the 6,000 square feet. Well, neither of us had been trained in architectural offices, and we didn't know why a budget could go so off. And so we said, okay, so let's see how this was budgeted. Let's imagine if we were building it, what would we do? We printed out the sheet of paper, which had essentially mass customized geometric points on every layer of a stacked wood system. It's like a brick system, though it's in wood. And imagine that we would hang a plumb bob to exact each intersection point, and realize by doing that we could probably do about 7 layers a day. If we could do 7 layers a day, we could probably achieve the construction in about 25 days. If you add about 5 to 10 days of tolerance, we could basically build it in a month or so for $30,000 with profit, leaving us an extra $170,000 from where the contractor left us. The understanding of the means and methods as a political instrument, and the architect not as the author of design intent, but rather the mechanism through which construction is exacted, was really that moment that we discovered. And again, I say this with a humility now, because I assume that most people around this table have already been through these exercises, but in the context that we were operating, this was not the case, and certainly still not the case in Boston, I should say. So the idea of absorbing, appropriating, and taking this geometry, internalizing it into our office, making it part of our design-build operation, and assuming responsibility for it was a central part of being able to translate these smaller scale installations in the context of some of the larger projects that we were invested in. While we were doing this, of course, we were also inventing systems. So for instance, in Casa La Roca, we understood that a brick wall like the serpentine wall in University of Virginia, or the Dieste walls in Uruguay, are interesting because of the optimization they give to a single layer of brick. But in fact, they do it with a level of imprecision, and they're also a structural concept. They're not able to absorb light or air through it. So we asked ourselves, what happens if we want to bring light and air into a very structurally optimal idea? So we said, imagine the mortar line not as a stable dimension. Imagine a bonding system not being a static concept. It's not a running bond, it's not a Flemish bond, but it's a variable bond. That dimension of the mortar can expand and contract at will parametrically. And by doing that, effectively fluctuate to where you want it to be, and effectively make another designer expand and contract them differently. That is the basis of what we were doing at the same time. We were building projects, but also we were imagining that we could invent systems that were shareable, that were deployable by others. This is, of course, before Etihad, before a lot of the other things that were happening digitally. This was happening at the cusp of the kind of hand-drawing moment and the digital moment. In turn, this was translated into actual projects here. This is the Tongxian project in Beijing, where the shrink wrapping of stairs and other programmatic elements were done as a formwork for concrete. Remember, Beijing is in a seismic zone, and so the brick, while working compressively, is very vulnerable to failure. So in fact, if you think of the brick as a formwork, as a permanent formwork for the concrete, then the ductility of the steel inside can do a lot for it. And so the brick essentially becomes a unitary metric by which you build the wall up 2 feet at a time, pour your concrete and your rebars in there, and build it up. And you can see here the connection between the staircase, the vertical cantilever of the brick wall, and its connection to the entryway. This begins to get revealed in also sometimes extraordinary conditions in the first phase that was completed, where the concrete is revealed in the northern elevation of the gatehouse. You can even see the underbelly with brick, which would appear structurally unsound, but once you understand that it is the formwork, it takes on a different meaning. And the variable bond here is enacted here by tilting the entire wall in relationship to the slope of the roof. So all of this is occurring in my mind in a scenario in which we as designers have certain cultural, formal, typological, and programmatic agendas. But we're realizing more and more and more that we're up against disciplines over which we have very little control. And in our case, in the arena of structural design, mechanical engineering, or engineering at large, we found ourselves constantly undereducated on the one hand, but also constantly thirsty in light of the consultancy model that dominates practice. So that's one of the reasons you see us constantly looking at engineering or at the exactitudes of the construction industry as the basis for our own speculations. So this image of the ground shows you the stubbornness with which architecture over the centuries has operated, because we have to stand on it, but how the ceiling or the domes often gain representations of the heavens, of the gods, and of extraordinary moments that are not subjected to the same programmatic determination. And for that, we did a little study for a space that needed to act as a lobby, quite flexibly, almost mundane, as a passage between three spaces, but with a sectional possibility of suspending something that indexed the way in which that space worked. And so the concept here was, what happens when you hang something, and what are the possibilities of making form with the act of hanging? You're all familiar with the experiments of Gaudi, the catenary chains, and the formal logics that emerge out of that, but also effectively in his world, how that's turned upside down to become vaulting systems. In our case, we asked ourselves, what happens when you not only hang a chain, but how you hang a chain in variable dimensions, but also what happens when you hang a chain from a chain, and what are the distortions that emerge from that? Hybridizing vaulting systems in relationship to each other. The sistering process of this vaulting enabled us to, in a way, map the three circulational trajectories, but also sister those vaults together as if merged together. Now, in this case, this was another one of these very economical projects, and it was meant to kind of materialize the possibility of the heavens, but in a very simple and straightforward process, really to build a cloud for a space that is corporate, relatively mundane, and made out of paper clips. These operations are part of the sort of the meat and potatoes of our practice, but we also enjoy inverting these and asking questions that are improbable. What happens when the catenary does not become the repository of questions about tensile operations, but compressive operations. Consider for a second the flat vault of the Escorial and how the keystone in that project is not on the center, but distributed throughout the length of the entire floor. Now imagine how you would have to hang a compressive system that interlocks each other such that the puzzling and the notching of the pieces effectively distributes that keystoning process across 30 feet. And this is the compressive catenary that we developed for the BSA project with these interlocking units on which you can stand. The overall weight of this is no more than 400 pounds, but as dense foam goes, it also has the possibility of creating a surface on which you stand. And so these operations, while formally alien to the projects that we're working on, take on different qualities when you ask different questions of the systems within which you're working. Much like this building, the Georgia Tech School of Architecture asked us to repurpose a high bay structure for which we developed the crib. In our case, we were more intent on radicalizing the expression of tensility and suspension as compared to the bridges that you see here. In this case, the spacing of those I-beams does not give surface effectively to the idea of suspension. So we were intent on thinning out the rods even more, creating the redundancy and shaping the crib, the studio spaces that are suspended within that, as part of the major refacilitation of that space. That same thing is true as we developed the LVL beams that span over 22 meters at the School of Architecture in Melbourne, where raw members of wood as coffered ceilings become the structural system from which the suspended studio is slung, giving emphasis to the ceiling. It's suspended over a coffered ceiling on the ground where there's another acoustic environment underneath it, creating different spaces of learning around within it, but also under it, and effectively becomes an index for the structural forces that are being enacted through the length, through the height of that studio. Compressive, massive at the top, veneer, thin and tensile by the time you get to the bottom. In a way, the surface of that project is a register of the forces that it is undergoing. Again, all of these as suspended projects, slung projects, hung projects. Every technology comes with its own history. And when asked to do an installation for SciArc, again, some 10 years ago, we discovered knots. These knots come from the maritime industry. Anybody who sails knows essentially that there is a sophistication, a function, if you like, and a method to the speed at which you can put a knot together for different purposes. This also became another means for us to exercise this idea of redundancy, to develop a tensegrity structure whose components are not made up of steel and wire, but rather rope and rope. Here, as a composite structure, the compressive members are composed with and dipped in resin, becoming stiff, whereas the white members are tensile and working with each other, much like other projects you've seen that extend the tradition of Gaudi to create in this context, I believe this is the Droch design chair, to create a tensegrity structure that is able to span about 30 feet. You know, sometimes it's not interesting to talk. So if you don't mind, there's a free association sometimes, and you can begin to see how these projects are translated into other circumstance. And I simply say that it's not necessary to say much about it, but really to imagine that the idea of tensegrity for us was interesting, not because it was a form, but because it's a system. It's a system that can go from a static condition to a much more dynamic condition, and therefore can be reformed from one condition here to a completely different condition here. That is the same project. There's no difference between this and this for us. But it has to do with its fine-tuning to circumstance. In the context of our project in the Gwangju Biennale, we wanted to translate the thicket of bamboo up in the air on the street corner where there was a lot of infrastructure underground, and we wanted to tap into that infrastructure while not contaminating the foundations by surgically, almost like acupuncture, occupying that ground, but creating a kind of thicket of a canopy above us that engaged the space above. Well, all of you who've studied Snelson understand that the difficulties and the dynamism that it takes to exact that structure. But nonetheless, we delivered the working drawings for this a week in advance, and the Koreans said they loved it. But would we mind if they changed all of the tensile members to also compressive? Would that change the idea? And of course, if this was an engineering discussion, there would be laughter now, but we had a crisis because effectively the whole project was killed in an instant. But we said, okay, what happens if we reconsider our own methodology in this process? Let's say we do not exact the metrics of this, and we think of the structural members all as compressive, but totally random. But we measure moments of structural stability by density. So we asked them, do you mind if we give you the form and we give you the density, but then you build it according to this recipe? But it's a recipe on randomness. So we told them, look at this. Here's the street corner. Here's the maximum dimension of an ellipse we want you to fill. There's 2 trees that are a void and an oculus to minimize materials. You're gonna build a cloud up there, and you're gonna connect it to the ground on these 5 or 6 points, and you're gonna penetrate the trees through them in the oculus, and you're gonna create a formwork that exacts this elliptical void. And what we're going to give you is a density of steel members. These steel members, by the way, are used door handles. The fabricator of this was not a fabricator. It was not a contractor. It was the person of the lock museum. He builds doors. He builds locks, basically. And there are essentially compressive forces, tensile forces, areas of density where the column capital has to, please.
Why did the client do
Anything in construction that requires exactitude costs money because it requires labor. This is a dumb and stupid system. So to the degree that you can create maximum ease and tolerance, makes it available to anybody to build it. And especially thinking of the long distances, the language barriers, what gets built on-site and off-site. If you build it off-site, you can control it in this different environment. The moment you take it on-site, it's double the cost. So effectively, people want ease. And so in this case, they're saying, well, we don't have drawings, so we can just build it however we want it. So we said, we all knew that if they can build it with 1,000 door handles, not 2,000, you've saved money. And if the measure of structural stability is by going to it and shaking it and saying, seems pretty stable. So that essentially became the metric of a swarm, if you like, of structural members whose optimization is based on an idea of the key moments that give lateral stability and compressive stability on the ground, not requiring added foundations. It's just tapped into steel members there. The evacuation of voids, as many voids above to lighten the cloud, but also the right density in the capital areas of the columns to distribute the forces out, and a minimum of 3 welds per rod, so that it's always triangulated to other members.
Interesting. Are you able to describe so precisely the needs?
How?
Yeah. I mean, if you start like, if you just start from density and the outer shape.
No, we gave them formwork for it. So if you give them the shape, you can build a plywood formwork for it within which this is built.
Mm-hmm.
So you're giving them the formwork, but you're not giving them what's inside the formwork. So to imagine the steel is like concrete that you're just pouring inside that formwork.
Okay, so the bit for formwork and then.
We did, yeah. Right. I use this slide effectively to show the distinctions between how we conceptualize figurative and configurative work. The bowl and the nest are virtually the same thing. The bowl is an exact platonic form that conceals its aggregate construction, though at a molecular level you may be able to identify a subcomponent of parts that make up its constitution. The way that it's polished, the way that it's smoothed out, essentially conceals its tectonics. On the right side, the nest, the bird has been very diligent about expressing every twig, every blade of grass that comes to build that form. The majority of our projects, as you can see, take bias on the right-hand side because, in a way, revealing the relationship between construction and the possible figures that it can produce are of interest to us, though recognizing, of course, the left side of the equation. Some years ago, we were very much fascinated by Ito's Todd's, not only in the way that figuratively the building takes on a kind of symbolic relationship with the trees in the foreground, but the prospect that it performs structurally in a certain way. So I bought my ticket to Tokyo to go see it and was left a little bit underwhelmed by realizing that it's really just a skin on top of a standard cast concrete modern building, if you like, with a round plan in certain areas that in a way expands on the ideas of the dock and the decorated shed, but stopping short of the possibilities of what the facade is suggestively doing or potentially doing in terms of the generation of form. So, having been shortlisted for the Issam Ferris Institute in Beirut, and this story takes on a heightened significance because it was us and 4 other young architects, as well as 1 alumna of the school who is now deceased, who won the project. We were sure that we could not win the competition because we were sure that the competition was rigged for the alumna. And in many ways, this is liberating because it enables you to do the project that you want to do. And in our project, we thrive not so much on an idea about authorship or uniqueness or identity, our identity that is, but rather disciplinary arguments and debates that migrate from one generation to the other. We were more interested in completing what we understood was an incomplete narrative in Ito's work than to pretend that we had something else to do. So start with Ito and we go forward. We wanted our building to establish a dialogue with the nature within which it was placed, not the architecture or the urbanism of the campus. Behind a row of palm trees, cedars, and ficus trees, we wanted the Isam Faris Institute to develop its morphology from the very roots of the trees within which it was embedded. But we had to develop a geometry, a series of architectural elements that could literally speak to those. So imagine a hexagon. When you truncate it, it becomes a triangle, and in that process could become a column. But if you expand it, it can become a pilotis. If you rotate it, it can transfer loads, or if you compress it, it can become a wall. This simple geometry and the compression and expansion of it from triangle to hexagon has just become 5 or 6 elements. Now, imagine in section, as you plant the roots of this in a foundation and grow this, it can become spatial at the bottom and envelop space. It can transfer loads somewhere in the middle as programs start to compete with each other. And of course, lighten up at the top where the loads are far less. So the branching effect takes place. Now, imagine this in the context of a domino frame, a simple classical frame within which you have smaller and larger spaces. If you have an auditorium, for instance, you need larger transfer beams that go above you. But also, if you have cantilevers on one side, you need a backspan that is deeper, and you need to accommodate for the floors of the auditorium that may be raked. Or you need to lighten the structure at the top. Imagine Ito's building as having a dynamic relationship between the inside and the outside, such that the skin is not necessarily a facade on that structure, but rather a mere extension of that whole edifice. This is all, of course, related to a series of structural systems, spatial systems in which we have been invested over the years. And in this case, for the ICA in Boston, we were asked to do an installation on George's Island. We were very much interested in this idea of coffered systems. The coffered systems are what I call 2.5-dimensional structural systems. They're not fully 3-dimensional because they're really a pattern that's extruded. In this case, extruded 3-dimensionally, but what's interesting about them is that they're able to establish a direct relationship with the ground, which is flat. They can arch, they can vault, they can extrude to become walls. So they have immense variability, but they can transform themselves to the exact conditions under which they are subjected. What you do not see in this image is the structural failure of this project. But anybody who understands the 101s of structure knows that if you put coffering, if coffering works with the flanges vertical, it has a great ability to span. But once you lay it on its side, it's like an accordion. It's flaccid. And so, by necessity, you can see the edges of the structure slumped, sadly in repose. What you don't see are the tensile members above that hold it into place. Requiring us to reconceptualize it completely in the context of a second version of it in China, in Beijing. And in this case saying, okay, we're going to do this again, but now one half of it is going to be in tension, the other half of it is going to be in compression, and we're going to start with the structure first and then go to the shape. So the figure 8 essentially describes the transition from tension to compression. Here, we did exactly what I was describing earlier about the Escorial vault. By displacing the keystone from the top of the vault all the way down to the bottom, you notice that you get a trapezoidal section on the right and left-hand sides, such that the distribution of loads is recentered on the vault itself, not on the walls. And by doing that, you can create a figure of a vault that in fact is able to take the very loads. This is not Photoshop, so this is the actual loads. But it shows also, despite all of the work and the research that we do, how so much of it is based on empirical failure and some level of innocence during the process. This is a collaboration with Adam Silverman at the National Museum, but it marks our interest in coffering systems not so much as patterns, but as real broad structural systems, in this case translated over 1/4 of a kilometer for the Kuwait Sports Shooting Club, that encompasses a large multi-use program, including but not limited to a hotel, housing, interior, water park, cinema, arena, and parking, all of which acquire a fifth facade, which is the reflected ceiling plan, that has this ability to migrate in terms of coffering from a triangle to a square, to a pentagon, to a hexagon. But the reasons for doing that is that this fifth facade, these shapes, as unitary elements, end up migrating and responding to the very programs to which they're adjusted. In other words, they go from square to hexagonal on the stairs. They go from the ocular conditions to the storefront conditions in the bazaar. They go from the running bone squares to the triangulated in the cinemas. That there's a direct confrontation between the unitary geometry of a coffering system and the larger shapes of the typologies that they uphold at a grander scale. Exacting the relationship between part and whole is very much part of our investment. We imagine, why is it that we take for granted that water can become snow, or ice, or crystals, or steam, that this change of state in the biological world, in the natural world, is taken for granted, and yet somehow in architecture we think of elements as having a static nature. What if you developed a brick that had the capacity, through its own constitution, to transform from a surface active system to a form active system to a vector active system. And so for our Georgia Tech research, we developed essentially this unit that was able to braid itself from a two-prong system to 4 and from 4 to 8, enabling a tectonic system that, as it grows from right to left, is able to go from a stacked system to a laterally braced wall system to a spanning truss to a cantilever, all through derivations of a single module that change in state as they go through the length of this installation. This in many ways takes us back between systems that are at once performative, but those systems that are also in service of the mechanical functions around which you just cannot navigate without an understanding of the subservience of skin to structure, or vice versa. Maybe the structure is in service of the skin. But for the bank restaurant, in effect, we realize that the plethora of infrastructure in a restaurant come from above, not from below. So if the architecture is conceived of upside down, we can suspend the architecture from above so precisely the floor can be empty. And in this, the structure, the mechanical systems, the sprinkler, the lighting, everything, even the wine room is suspended from above precisely so that the floor can be evacuated of all of the chairs and tables for parties and events and all of that, but recognizing that somehow the expression of the space is based on a theatrical mechanism of the proscenium to create a figure-ground relationship between the black painted background and the plywood foreground in order to do so. How are we doing?
We're good. 10:30, right? So we have 15 minutes more, or a little bit more if you have time.
I can go to the last project now if you want to open it to discussion.
Yes,
How about that?
yeah, let's do that.
So we're almost at the end, and I just want to maybe go to this last project, which effectively is about to be completed and represents the messy and complex terrain that is practice and the small things we fight for in making projects what they are. In this case, I'll compress it to one discussion, and it is this section that produces the studio hall space, on top of which there's this folded roof. That folded roof gives us the promise of integrating a structural system, the Firth of Forth Bridge, that enables the precise trajectories of the water on the roof to come to the sides to go to the cisterns and harvest that water for the landscape, but also bring natural daylighting into the space. The idea that there's only 2 or 3 shapes that can achieve this, and this is one of them, was central to an argument for us to fight for rather than the boxed roof. This is all in the context of a very, very complex system of metrics, whereby the extension onto a historical building had to measure the levels of insulation that we had to have, the amount of energy use, the adoption of a green roof, natural daylighting, and the conception of each floor as a piece of landscape. The floors in this are not static, but they connect to each other, they reach out into the landscape, and they try to minimize the use of artificial lighting and essentially programming them for the nights in ways that are beneficial for the building at large, but also tapping into the infrastructure of the city, the subway systems, the biking networks, the pedestrian systems, to imagine that this is part of a larger ecology, not only of the campus, but of the neighborhood at large. Operating on the building as a piece of urbanism, but also as a piece of building technology that operates in the microsection, we were looking at displacement ventilation in the context of that roof system to remove pollutants. We were looking at ways of saving on electrical costs. As I said, collecting the water, not only sending it to drainage systems, but harvesting it for the landscape around it. And then creating a figure for the building. Essentially, the facade of the building extends and inverts the Gothic silhouette of the building into a drainage slot that then integrates it back to the landscape and a kind of harvesting pool. Now, all of this is a narrative that seems to go together extremely well in service of a kind of destination, the ultimate space of the studio, where flexibility, a long span structure, and the ability to transform itself over the decades seems like a very promising thing, all of which has been under the gun and subject to death for the last 5 years. So much so that we realize we've lost it. This is not going to happen. Just like the Mantra project, this is dead. So we said, okay, what happens if we explain to them the principle of a ruled surface, that these are just sheet materials, it's just chipboard, and by the way, you can put the heating system within that chipboard and actually use it as the mechanical system. We could illustrate it for them. We could build it in our own shop. We're going to build half of that span inside our own shop and demonstrate how you can make this with sticks. Each of these are light gauge framing. You can see the way in which the holes in the light gauge framing align with each other, and therefore you can sort of run all of the conduits in there. And essentially any of the displacement that is in the sheet material can be spackled and covered together. Effectively, going really to the mat in the trenches with the contractors and the subcontractors to enable something like this to happen. And well, what can I say? Somehow this project hopes to be completed in the next 3 months. We'll figure that out. Anyway, I'll open this up to discussion now and just to receive questions and or comments.
So let's open up the discussion. We have about 10 minutes. I'm sure there are a lot of questions here, but also questions from the other nodes globally.
Marcella, let's put back the video.
Yes, okay. So we stop share screen right now.
Should I stop the share screen?
Yeah, exactly. Let's activate just your camera.
Okay, hold on, let's go screen share.
And then
Oh wait, stop.
stop sharing. Turn off
Perfect.
right here.
Like this?
No, yeah. If you click back to the icon of this of the video, of the camera, it will turn on, so we can see you.
Did I do it? Or?
Yeah, perfect. Like this, it's perfect.
All right, sorry. Somebody was asking.
A lot of contemporary trends with architects like responding to programmatic demands and having like a pragmatic approach to building different construction systems.
I apologize.
Run machine.
the vast of possibilities for invention through through material explorations, spatial explorations, mechanical, structural explorations, that there is a possibility of the redefinition of the discipline through expansion of our own country. And I think actually the next generation has radicalized already. What has been difficult is how one does that in a way that does not lose one's control. Is part of it. So how do you gain that kind of currency through collaboration has now become the big issue, because effectively anybody can do an incredible range of work at one single laptop, one single station, what was impossible 5 years ago. But the wealth of knowledge that we need, the specialization of other people, have also led to just a different conception of things. Even if you look at their practice, the idea that maybe the discipline is not at the core of architecture, but is displaced in physics or in electrical engineering or somewhere else. And I think the building industry is not well situated to absorb that right now. So to the degree, and our practice is really stuck, if you like, between its aspects of research and engineering, but also the willfulness trying to take on, great commissions that have the incredible weight of influence and mandates that are very traditional, and how to reconcile the possibility of speculation under such radical control is really what, for me, is daunting. Still, I suppose that some people are able to get around that through power or the agency of authorship. For the sake of the argument, I'm going to put Gary on that end, or the idea of being recognized as such, or others who do not require commissions as such, but are self-motivated by research and research alone, but are then operating on the fringes, let's say. So I think it's an interesting moment, but I don't have a good answer for you, because I find that the explosion of what is possible in the world right now, amazing, the result of communication and the sharing of knowledge. I mean, I'm speaking to Tehran on the other side right now. When I went to Tehran 10 years ago, it was in the 1970s. But if you look at the kind of work that is being done there right now, it is arguable that they can do more research and speculation than you can do here, because they don't have the same constraints. And so the omnipresence of technology on the one hand, but the difference in processes of procurement, legislation, and ideological freedom, actually, even under conditions of extreme repression, are sometimes more liberating than what we have here, where everything is mandated by insurance, products, conventions, and so forth. So I think this is what's daunting right now. How do you create a space of invention in the web of regulatory mandates that practice gives you? Think of the work of Saracena, a great architect, or let's say maybe not a great architect, let's say a standard or maybe cool architect who could not do anything in architecture, but in the context of the art world could radicalize what architecture can do. I mean, that to me is another great alternative.
Are there any questions from the other nodes? Aldo?
I have a comment, and then I also think that we can close the lecture. But first, I just want to make a comment. You know, during the presentation, and congratulations, of course, for your incredible work. But you talk about the negotiation of material properties, mechanical systems, and the definition of, you know, special needs. So basically, you are proving that you can master those forces and produce so many rich results. You know, I'm wondering, as architects, how much we are able to do the same, but at the scale of the city. You know, so the Global Summer School is mainly focused on the possibility of those cities to grow, to become, let's say, to address the complexity that we are now living in, and to bring this complexity into, transform this complex system into a better place where to live, no? So transform those city into a better mechanism that also is connected to the nature and all the other agents that are part of the city itself. I'm just really wondering, looking at this beautiful work that I think it's really impressive that you do, how effective we can be, you know, when we scale up our abilities, you know, like the one that you are proving to have. From
Well,
the
look, first of all, there is this propensity to say that, you know, we're designers and therefore we design vases, we design tables, we design rooms, we design buildings, and we design cities. And we know many architects that by desire and by practice are able to kind of go through that translation in scales. But the reality is also that the constituent elements of urbanism are in many ways very different than architecture, and what you control is different. So sometimes in architecture you control the specifications of materiality, details, geometry, and everything. But other times in architecture you control constraints for systems, but then let everything else be kind of self-organized by the conditions of culture, the site, the circumstances. If I can tap into a cliche, you know, it's different maybe to develop a classical score than a score for jazz, where in one case you're developing a framework within which people can improvise, and in the other case there is a kind of hierarchical system where the conductor establishes a direct relationship between part and whole. I think in the city you have to have a slightly different kind of discussion than the one I've been having today. And I should say as a preface that my education took me to urbanism in my graduate school, but I don't think I said anything about urbanism today, even in those moments where buildings were responding to the conditions of the city. I don't count that as part of your question. I think your question about forces that have to do with the investment of the city and the state in the city is one thing. Privatization and the impact that neoliberalism has had on the evolution of the city since Reagan has radically changed the way that we see the city. The notion of public works as exemplified in Barcelona of the 1990s is very different than the concept of a 10% mandated, controlled, surveilled space in a mall in the United States. These are both conceptually public spaces, but they really mean different things. I think the definition of infrastructure in the eyes of traffic engineering are one thing, in the eyes of people in service of human rights, if you like, in the occupation of citizens and their conception of the city as a place of living is completely different. So we're witnessing right now a a kind of incredible moment, potentially, where the forces of privatization that you've been witnessing since, essentially 1980 till today, are becoming tested through, well, the big economic meltdown, through, in many ways, technologies. Think of Black Lives Matter and the way in which the private realm of a cell phone has become very much public and enables, empowers us to be able to operate within the city in a completely different way. All of these, in my mind, are changing questions of scale to urbanism. Now, having said that, when you build a city, you're not trying necessarily to control every building in the same way. The question is, are you trying to establish continuity of public access in the way that I'm speaking right now in terms of the politics of the city? Or are you trying to control, as Andres Duani would have, the character, the materiality, the typology, and the grain of a type of city that he would have us envision as the domain of a civic space, even though it's privately developed? I think these are the kinds of questions we need to ask if we're going to talk about the city. So maybe your question has more to do with the political frameworks that enable us to imagine what is the civic realm of today.
Probably. On the other side, probably I'm also thinking that we should be questioning also the tools that we use in order to design the city. In the same way that we are, exploring the tools that we use in order to design a building, probably are not, the appropriate ones, or we should, address or explore other kind of tools that can really address the complexity that a city has. I mean, it's probably another kind of discussion that can bring us.
Look, you're probably. I mean, look at all of the way in which data is gathered today. Look at the knowledge that you have of the city today. Just 20 years ago, 25 years ago, people were doing figure grounds of the city. It showed something. I'm not critical so much of what it showed, but what is amazing about it is what it eclipsed. What you know about the flows of business, the flows of people, the flows of capital, about traffic management, about the nature of boundaries is exponentially more today than any time before, and that is in great part linked to your question about how we research the city. And I should say, by extension, the problem maybe with the conceptualization of your question about the city is that we're not only as much impacted by our thinking about the city today as about geography in general, because our environmental problems are not related to the city, but are transnational as they deal with a larger scale, and that's becoming harder and harder to contend with. So urbanism, as we think of it right now, has a much more global reach in my mind. And I don't think we have developed programs of urbanism that have a very palpable way of addressing that scale. So I think that your question has much more far-reaching impacts than certainly what I'm able to present, but people are working on it, let's say.
Thank you. So I would like to now just direct the last question to our friends in Tehran. So they would like to ask you something else, and then we can close this beautiful global lecture. So Tehran, your micro now should be on.
Can you hear us?
We can hear you.
Great.
Hello from Tehran.
Hello.
As we are studying interaction, innovation, urban system now, my question is mostly same as him. What do you think about the smartification and interaction system and objects that we can add it to the city and the houses, and how it can be affect to the people and life?
I'm sorry, could you repeat that? I'm not sure exactly. Could you just repeat that one more time, please?
We can't hear anything.
Could you repeat one more time, please? You froze for a second.
Mute. Could you repeat the question?
I cannot hear you.
Can you repeat the question? Repeat.
ये बार दिखे मैं
No, we can't.
I think it's about smart. Smart.
Oh, there you go.
Repeat the question.
Iran, can you hear?
نه اینترنت نداره اسپیکرامو کار میکنن
Just use your computer.
منو میشنوی؟
من فکر کنم که صدا.
از اون داره
Maybe
Can you hear us?
right now.
We can hear you, yes.
Oh yeah. So I repeat it again. Sorry. I ask, as we are studying the interaction, innovation, urban system now. I want to know what is your opinion about smartification objects and the city and how it can be affect to the people and people life.
Yeah, you know, it's the first time I hear the word smartification, but no, look, I mean, in part I was referring to the ways in which data gathering is transforming our knowledge of the world today. We are sensory beings in a geography, in a space that maybe 500 square feet around us, but we're also sensing environments way beyond ourselves and are able to tap into information far beyond what we can imagine, or what we could have imagined 10, 20 years ago. In many ways, the smartest of us today is the person who is the best librarian. In the old days, we used to go to the libraries, and you'd have to understand what each of those aisles was and where the archives were. And now, there are some people that know how to Google and some people that don't know how to Google. So being able to navigate the archives of the internet in many ways is as much of anything as being able to inhabit the city. I don't know. I mean, I think I'll respond to your question by simply saying that the gathering of information and the procurement of data is one of the most critical aspects of being able to be conscious about your position in the world. And yet, that is a far cry from that projective act that a designer makes, whether at the scale of a table, a building, or the city. So, to some ends, the reason why I'm not able completely to answer either your question or the previous one is because they are open-ended questions. They don't ask specifically about that moment where you bring a thesis to the equation of the city. The reason I brought up the question of privatization in the context of a mall is because we know that that is not free space. Now you know, and I know, that I can't exactly comment on the nature of the political system in Iran right now, for your safety and for the safety of others. But we well know that each political system enables us, within the confines of certain constraints, to radicalize the terms of an aesthetic project. The death of Kiarostami is one of those moments that should act as a kind of perfect anecdote for what could be done in urbanism today. We constantly have constraints, we constantly have censors, and we delicately slalom our way to imagine what is a possible alternative world given the frameworks that are set for us. Does that satisfy your question?
On mute.
You're on mute.
You are on mute.
Yeah, yeah, I got my answer. Thank you so much.
Great.
Okay, so now I'm gonna do the bad guy again, and I'm gonna close this last global lecture. It was a beautiful lecture, and I think we couldn't close in a better way than this. So congratulations to New York for organizing such a beautiful closure. And yes, it's time for us to go back to work, and we will be working on an installation. So it was again, it was in perfect timing. And yeah, thank you, Nader, for your talk. It has been recorded, and again, it will be shared with all our students and with all the other nodes that are connected with us. So Beijing, Beirut, Shanghai, Tehran, New York, Moscow, Barcelona, and many others. It has been a pleasure, and actually we made it. More or less, we gave to all the other nodes the possibility to connect and talk about their research and what they have been doing. So from Barcelona, that's all. We can close the lecture. We will talk again on Sunday for the presentation of the final projects. Thank you.
For the people in Barcelona, I'm coming there next week. I hope to drop by and say hello.
Absolutely, you are welcome here. We will wait for you.
All right, bye-bye.
So thank you. Bye.
Bye, everybody. Bye. Bye.
Bye.